Welcome to all for today's class. In this class, we are going to learn about the closed mold processes in the composite fiber manufacturing. About the closed mold processing, they are advanced manufacturing techniques. These are the advanced manufacturing techniques used to produce high performance fiber reinforced polymer. That means the FRP components with the superior surface finish, strength, and consistency. These processes involve enclosing the fiber reinforcement and resin between two halves of the mold, allowing for controlled resin flow, high pressure application, and automated production. Compared to open molding, closed mold processes provide better part quality, minimal emissions, and are well suited for mass production. These methods are increasingly used in aerospace, automotive, wind energy, and high-end consumer goods manufacturing. Why closed mold? These are very much essential to have the enhanced part performance, two-sided surface finish, high reproducibility and dimensional accuracy, high as well as the emissions reduction is higher. That is environmentally it is safer, also suitable for automation and robotics also. What are the key closed mold processes? The processes involved in the closed molding process are one is resin transfer molding. It is called RTM, resin transfer molding, compression molding, vacuum assisted resin transfer molding, resin film infusion, matched die molding, structural reaction injection molding, pultrusion. Technically, it is a continuous but a closed mold one. Then injection molding with thermoplastics. These are the mold. There is a closed mold processes. In the resin transfer molding, the process involves placing the dry fiber reinforcement into a closed matched die mold, followed by injection of catalyst resin under pressure. After curing, the mold is opened and the composite part is removed. The steps involved are dry fibers or performs are laid in the mold cavity. Mold is closed and clamped. The third one is the resin is injected under pressure about 0.5 to 7 bar. Resin impregnates the fiber and fills the mold. And then curing occurs at room temperature. Until the mold is opened and the part is rejected. These are the steps. And in RTM, the advantages is high quality as well as wide free parts are obtained. Two-sided smooth finish will be obtained. Then suited for complex geometry as well as applications point of view, automotive parts, aerospace parts, industrial equipment. Especially in automotive means it is automotive panels. In compression molding, a pre-measured charge of thermoset resin and fiber is placed in a heater mold cavity. When pressure is applied via the mold holes, the material spreads and fills the cavity, curing and heat. Here the steps are material is loaded into the open mold and the mold is closed after applying the pressure and the heat. Material flows and cures inside the mold. Finally, the part is removed and trimmed. Here the advantages are cycle times are faster, scrap rate is low, good surface finish and strength, and it is suited for the automation. Finally, the applications are electrical enclosures, automotive structural parts, helmet shields are being done in the resin transfer molding. Then vacuum assisted resin transfer molding. Here, where the vacuum is used to pull resin into the fiber preform inside the sealed cavity. Unlike resin transfer molding, it uses atmospheric pressure difference rather than the mechanical pumps. It is a very important difference between the resin transfer molding versus vacuum assisted resin transfer molding. Then steps are similar. As well as advantages are equipment cost is lesser, as well as resin waste is lesser. Uh, Large parts maybe manufactured here with a good surface finish. As well as applications here is wind turbine blades, board hulls, and the composite panels we manufactured here. Finally, the resin film infusion here. Resin film is placed between the dry fiber layers in a mold, then heat is applied to melt the resin and allow it to flow the fibers. Here, the advantages of the resin control is precise and fiber content is higher. Thickness point of view, it is a uniform thickness can maintain here. Its applications are aerospace panels, high-end automatic components. Finally, one more molding is there. There is match die molding. Here the steps is we have to lay the form in the lower die, close upper die, and apply the pressure. Then heat cures the resin. That is the thermoset resin, and as well as the part is demold. The advantages is cycle time is fast, high quality surface, part geometry precision is higher. Applications are mass produced structural parts, seating systems, aerospace brackets. So these are all the things in the closed model as well as pultrusion. Pultrusion already discussed in the previous class. And one more thing is there is the thermoplastic injection molding. It's nothing but a fiber reinforced process. With a short or long fiber reinforced thermoplastics are melted and injected into the metal mold under high pressure. The steps here is material melted in the barrel and injected into the mold cavity, finally cooled and injected. The advantages are the same thing, but here the main advantage is high volume production. Complex geometry can be manufactured here, and the applications are electrical housing can be done, sports equipment, lightweight buckets. So these are the closed mold processes. The main thing is superior quality we can obtain, environmental safety, repeatability, complex shapes, automatic automation ready. These are the main advantages of the closed mold processes when compared to the open mold process. Um, Finally, we can have a summary about closed mold process. Have revolutionized the production of fiber reinforced composites, offering the superior mechanical properties, excellent surface finish, efficiency in mass production. That's all in this today's class. We will see the another topic with important notes in the next class. Thank you for your participation. Thank you and all.